Okay, so today the main goal is to talk about transformations of functions in general, and I'm going to use an example of a parabola and an example of an absolute value to do that. A lot of this stuff is going to mirror or be similar to 1.0c and 1.0d that we've already talked about when we did our review material, so hopefully some of it looks familiar. The notation here is different than what you've seen in in Math 2. But the transformations are going to be similar. So the value of A affects the graph in two different ways. If it's negative, it causes a vertical transformation. And then whatever the value can cause a vertical stretch or shrink. The stretch occurs when the absolute value is greater than 1, and the shrink occurs when the absolute value is between 0 and 1. F of x represents any function. So far, the functions we've been reviewing are these three from Math 2, a linear function, a quadratic function, and an absolute value function. If the number in front of x is negative, then that causes a horizontal reflection. And depending on the value of b, causes a horizontal stretch or shrink. Now, this is a new idea that we haven't talked about before in previous math classes. And we will touch on a little bit here for exposure. We won't do a lot of it, but something to be aware of. I can stretch things vertically. And I can compress things horizontally and get the same result. So it gets a little convoluted. The C, just like before, causes a horizontal shift. And the positive number actually moves to the left and negative number actually moves to the right. And whatever I add and subtract outside the argument causes a vertical shift. Positive number moves up and a negative number moves down. This is so much information. I understand that. Take it in a little bit at a time. We will be using this structure all year long. You will get good at it. The sooner you understand it, the more beneficial it will be. All right. But there's a lot of symbols. There's a lot of terminology. Remember, we're just starting out. Whole nother level of math. I'm going to use this term, the argument, a lot. It's basically how I'm shifting x horizontally, right? So the argument is what is like the input value right here. Whatever this is going to be my argument. Again, the more I use it, the more you'll get used to it. Okay, so we're going to start working through this. All these information is going to start disappearing. So hopefully you've got it all written down. Okay, so for this, I have like 2 examples, f of x and g of x, and then I have like 4 things we're going to answer for each problem. So if you want to draw a chart, if that's convenient for you, the chart function doesn't work really great in OneNote. But basically, I'm going to have like A, B, C, D that we're going to answer for f of x and g of x. I'm going to color coordinate mine so it's easier for you to tell. So f of x is equal to negative parentheses x minus 2 quantity squared minus 3. Describe the transformation from the parent function. So reminder, what is the parent function? This symbol f with a little n is a shorthand for function. So you'll see me write that if you haven't seen that symbol before. So the parent function of a quadratic is f of x is equal to x squared. anything that's not x squared over here is a transformation. So this negative, the -2, the -3, all of that causes a transformation. If there is a negative in front of the parentheses of the argument, this automatically causes a vertical reflection. I don't know if Pearson, yeah, it probably differentiates between vertical and horizontal. So vertical reflection, it could be caused that, well, I'm going to take that back. I think that they call it a reflection across the x-axis. I'll make a note that they're the same thing. So I'm going to add a note right here in this red. That's supposed to say across. A vertical reflection is across the x-axis, and a horizontal reflection is across the y-axis. When we pull up the homework, I'll clarify, but a reflection across the x-axis and a vertical reflection are the same thing. All right. So then a -2 inside the parentheses, I have x -2. Anything inside the parentheses that's in the argument causes a change horizontally, right? Because my original equation is already x minus some number, remember this -2 is going to move kind of backwards of how we think. So instead of going left 2, this actually goes right 2. Because it's a -2, it's going to move to the right. So this is going to shift right 2. The thing that's happening outside the argument, that causes a vertical shift or vertical change. So the -3, if it's subtraction, I'm going to move down. So this is going to be a shift down 3. B, name the vertex and axis of symmetry. We're going to get to the graphing below, but if I kind of just map this out in my mind a little bit, for a parent function, my vertex is at 0, 0. But I just said that I'm going to shift this right 2 and down 3. So that my new vertex is going to be 2, -3, right 2, down 3. So my vertex right here is going to be right 2, down 3. Now, if you needed to graph and then go back to this, you totally could. You could graph it on some paper and then go back and answer what is the vertex. Now, axis of symmetry can be a lot of different things. We can have axis of symmetry that are vertical, horizontal, a line with a slope, all kinds of things. For these functions that we've studied before, the axis of symmetry is a vertical line. The axis of symmetry is that line that goes through the graph. If it's a parabola that opens up, it goes through the graph vertically, and it basically causes a mirror image, right? This left side is a mirror image of the right side. That's the axis of symmetry. It's the line where the graph is symmetrical. The equation for the axis of symmetry for a vertical line is going to be always x equals whatever the h value of the vertex is. So if my graph, and we're going to get to the graph in a minute, if my graph opens down and I have a vertex at 2, -3, the axis of symmetry goes through there, which is x equals 2. It's just this value of the vertex. So if you know the vertex, you already know the axis of symmetry of a parabola. The axis of symmetry is an equation of a line. So you have to tell me x equals that number, not just tell me that it's 2. The next part is to actually graph the function and the axis of symmetry. When we graph the axis of symmetry, we're always going to make it dashed. You guys by now, we're in week 4, so I'm sure you have graph paper available since we do a lot of graphing in this class. So I just put in some graph paper right here so that I can be more accurate. So we already found the vertex and the axis of symmetry. I'm going to put that on my graph. My vertex is at 2, -3. And my axis of symmetry goes through the vertex. In this case, it's going to be a vertical line through the vertex. On Pearson, on your homework, it will ask you to make the axis of symmetry dashed. That's a feature of the graphing window. You can make it solid or you can make it dashed. If you make it solid, it's going to think that you mean that that's part of the actual function, and it'll mark it wrong. I can show you what I mean when we're done. Now, in order to find the next point of the graph, I have some options. I could take my original function and I could plug in some other point. So I know if I plug in 2, I get -3. If I plug in 1, what number would I get? I could plug in 1 and get a point. I could plug in 0 and get another point and graph it like that. You could also graph it using that kind of rule that we went over, which is that if I have a function with a of 1, I know that the parent function moves up 1 to get to the next point and up 3 more to get to the next point. And you could keep going, up 1, up 3, and up 5 to get to the point after that. So I like to use that when I'm graphing. It seems easier, but you are absolutely welcome to just plug in some points and fill in a table. Looking at this function, right? Boop, 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 boop. I know that a is -1, so it's going to open down, right? But a is just 1. It's not going to, I'm not going to have a different stretch or shrink. So that reflection across the x-axis is what causes this to flip. So I go over 1, down 1, and then over 1, down 3. And that will give me a shape of this graph. Okay, so the last part of this kind of series of questions is let's talk about domain and range. So more opportunities to practice what we did in 1-1. Yes. The more times you see it, the easier it gets, hopefully. So domain are all the possible x values. If I look at this graph, to the left forever and to the right forever, it keeps going. Now I know it goes down a lot faster than it goes wide, but it still continues in this general direction. Any number that I have for x, any real number, I can plug into this function and it will give me an answer. So my domain is going to be -infinity to positive infinity. My range, look vertically. So it goes down forever, but it does not go up forever. My top y number is -3. So it goes up to -3 and it does not go beyond. So it goes from -infinity to -3. It includes the point -3. So I have a square bracket. Whew. We're going to do all of that again for an absolute value function. But this is not exactly all new material. So I'm going to pause for a couple minutes. If you're letting that sink in, cool. If you need to go back and reread a piece of that, cool. If you want to try, I think that from the information we've already done, you should probably be able to do all of these parts. But if you can go through and even do like maybe 2 of the 4 parts, go ahead and give it a shot. So there's the function g of x is equal to 2 times the absolute value of x minus 1. Remember that an absolute value function looks like a v. So just see what you can answer for that function. The transformation, vertex, axis of symmetry, graphing, domain, and range. Just as much as you can. And it's okay if you can't get it all. Any pieces of it is better than no piece. Maybe you were able to put something down for all 4 sections. Awesome. Maybe you were able to only put one thing down. That's okay. Maybe whatever you put down is wrong and maybe it's right. It doesn't matter because this is part of the learning process, okay? As long as you tried and you wrote something down, I am happy. What I would like you to do is I want you to talk to your classmates for a minute or two. Compare answers. And if you're embarrassed because you're like, dude, I don't know what I'm doing, that's okay. You're not alone, believe me. Go ahead, talk about your answers with a classmate and flesh it out and see if you can agree with anything or talk something out. If you see somebody that's like behind you or next to you who doesn't have anybody to talk to, feel free to move over there and talk to that person. I just want everybody to be able to talk to somebody. Go.
That's exactly one. The right person, like the left finger. This is two. No, this would be the vertex would be two things. Your vertex is not one. Yeah. It's a vertex because you don't. For the absolute value, remember I'm tired. I'm pretty sure I got it.
Okay, let's see what you can like mentally give yourself like kudos for, points for. Describe the transformation from the parent function. So in this case, there's actually only 2 transformations. The 2 changes from the parent function, and then the -1 changes from the parent function. So there's 2 transformations. One of them is the 2 is going to cause a vertical stretch of 2 or by 2. It's going to be a stretch because the absolute value of that is bigger than 1. If it's like 3, 5, I don't know, 3.5, it's going to cause a stretch. The -1 inside the brackets, inside the absolute value, is going to cause a horizontal shift. But it doesn't move to the left because it says minus. It's actually going to shift right 1. Sketches are very helpful when you're trying to work through these things in your mind, especially before you get really good at them. So we know that the graph of an absolute value is a V, opens up with a slope of 1 and -1, and the vertex is at 0, 0. Now for this function, we just said the only shift that happens is it goes right 1. All right, so now I've got this as my vertex. What is that coordinate? 1, 0. The axis of symmetry for an absolute value function that opens up or down is always going to be a vertical line that goes through the vertex. Here's the vertex. Vertical line that goes through the vertex, right, is an equation of a line with x equals whatever the x coordinate of the vertex is. So in this case, right, I have a 1, so x is equal to 1 is my axis of symmetry. Any questions on transformation or vertex and axis of symmetry? The more you ask, the more you know. Okay. You don't look panicked, so that's good. All right. Graph the function and the axis of symmetry. So far, we said that the vertex was at 1, 0. And I know my axis of symmetry goes through. Make it a little bolder so you can see it a little better, maybe. And in this case, reminder, we have a stretch of 2. For the parent function, I have a is equal to 1 and a is equal to negative 1. But now I have a slope of 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, and have a slope of 2 and negative 2. So when I do that really precisely, let's see. Up 2 over 1, up 2 over 1. Axis of symmetry means that that's the line that cuts the graph into 2 mirror images of each other. And it cuts it right down the middle. It opens up since it's positive, just like the parent function. And I want you to take another maybe 30 seconds or so. And even if you couldn't answer the domain and range before, maybe now that you have the graph, you can do it. So please write something down. So the domain is much the same for a lot of our functions. It's going to be negative infinity to infinity. But the range we see change a lot. So I always want to go from the smallest number to the largest number. The smallest number vertically of this is at the vertex, but the y value is 0, right? So it goes from 0 up to infinity. It includes 0, so I have square bracket, 0, comma, infinity, round parenthesis. Hopefully you got that. Hopefully you're improving. If domain and range has been tough. Questions on domain and range. Questions on the graph. This is a very quiet class. This is quite unlike my 5th period. It tends to be the case, though. You guys' morning class is usually all quieter than your afternoon classes. Yeah. It's like a blessing and a curse. Okay. We've got 2 different types of problems to go. In example 2, we're going to talk about transforming, instead of from the parent function to a new function, from 2 non-parent functions. Or from a non-parent function to a non-parent function. And then we're going to write equations from graphs, which we did 2 weeks ago, but good reminder. I find it really helpful to draw little sketches here, especially for when you're talking about the vertex or the y-intercepts. The 2 that we're doing here are linear examples. We can apply a similar idea for if these weren't lines. But to find the transformation in slope, I want to take the final slope divided by the original slope, and that'll give me the rate at which they change. Now, if it doesn't have slope, if it's a parabola, then you're just to find the change in A, you would take the final A divided by the original A. So much to remember from previous math classes. I know. Remember the equation of a line in slope-intercept form. Mx plus b, where m is the slope and b is the y-intercept. So I'm starting at f of x and I'm moving to g of x. So to find the change in slope, I'm going to take 1/4, which is my final slope, divided by my original slope, which is 2. Sometimes when I've got a fraction and a fraction, that throws us a little bit and makes things a little bit confusing. I can write this a different way. Instead of dividing, I can do 1/4 times. Instead of dividing by a number, I can always multiply by the reciprocal. The reciprocal of 2/1 is 1/2, which gives me 1/8. If this number has an absolute value of larger than 1, then it's a stretch. Otherwise, if it's smaller than 1, then we call this a shrink. By 1/8. Visual aids are definitely helpful. F of x has a y-intercept of -1. And g of x has a y-intercept of 3. So what's the change? To go from f of x to g of x, I'm going to shift up 4. So that's my change, up 4. So here's my answer, shrink by 1/8 and up 4. So it works the same for example B. Give you a little bit of time to see if you can answer for part B. So what is this stretch or the shrink, and how does it shift vertically? From f of x to b of x. All right, so when I look at the stretch or shrink, I'm going to look at the slope of the final, which is 3, divided by the slope of the initial, which is a half. Now, that whole fraction and fraction thing is kind of funky. So instead of dividing by a fraction, I'm going to multiply by the reciprocal. 3 times 2 gives me 6. Since 6 is greater than 1, it's going to be a stretch instead of a shrink. So if you wrote shrink by 6 and you were really, really close, just change that word to stretch, since 6 is a big number. For the vertical shift, so the original function had a y-intercept of 4, and then the new function has a y-intercept of 0. So to get from 4 to 0, I just go down 4. For example 3, I'm going to write the function in vertex form using 2 points, and then I'll relate it back to the graph and show you how you might have been able to do it otherwise. But please copy down this graph. So A is a parabola, it opens down. It has a vertex at negative 1, 4. It crosses the y-axis at 2. It also hits this point down here, negative 3, negative 4. Okay, so bringing it back to vertex form of a parabola, here we go. Y is equal to a times parentheses x minus h quantity squared plus k. Now you're welcome to write y equals or f of x equals as long as you know that they're the same thing. That way, what on a test or homework, when it asks you to do it a certain way, you'll be able to recognize. The easiest part to plug in is the vertex, hk. So in that case, I have negative 1, 4. Hopefully you can see that. I don't know if the red is bold enough for you to see. So that's going to go in for the HK. X minus H. H is -1, so it's going to be minus -1. I'll have a +1. And then K is 4. Check and make sure that you're good with why it changed to X plus 1. I'm going to use this other point to write my equation. And this is really handy because they don't always give you a graph. Sometimes they just give you 2 points. So this other point right here, -3, -4 is part of my graph. And I'm going to plug that in for xy. That'll give me a when I solve. And then I'll plug it back in at the end. So this is the tactic that I'm using. I'm using this other point, right? -3, -4. So y is -4. I'm looking for a. X is -3. And now I'm going to take this and I'm going to simplify and solve for a and then plug back a at the end to have my final equation. So I start simplifying using my order of operations. I start inside the parentheses first. -3 plus 1 gives me -2. As I'm simplifying, I'm still using order of operations on the right-hand side. -2 squared is 4. And since I'm done simplifying on the right-hand side, there's nothing else I can do. I'm going to start solving. To solve for a, I know there's a lot of 4's going on in there. But I'm going to subtract 4. -4 minus 4 is -8. -8 is equal to 4a. And I get a is equal to -2. When I've written a function for a graph, complete with all the numbers, the only variables are going to be the x and the y. So I replace a with -2. And I still have my x plus 1 squared and my plus 4. That's the equation of this graph. When we looked at this graph a couple of weeks ago, we talked about if I have a picture, if I have the graph and I want to write the equation, there's an easier way for me to get a. So I want to recognize that. And the easier way was that if I start from the vertex and I go to the next point to the right or to the left, that vertical change gives me a. So if I'm at the vertex and I'm going to the next point to the right, right, 1 to the right, what is this change? It's -2. That is a. Yes, I could have jumped right to that. But I wanted to work out the whole thing in case they just give you 2 points instead of a graph. So now you have an example that'll work for both scenarios. next one's a little easier. Last one. Jeremy Thompson. Uh-huh. Is he leaving? Thank you. Okay, that was for you. You're going home. Yeah. All right. So, like we previously talked about, the equation for an absolute value function in vertex form is y is equal to a times the absolute value of x minus h quantity squared plus, plus k. This is easier because a is the slope. The point that this graph hits is negative 2, 0, and the vertex is at 1, negative 2. Okay. So I can go over a couple of ways to find this. One, HK is just the vertex. So I'm going to plug in 1, negative 2 for HK. So I start there. X minus H is 1. Ooh, goodness, somebody stop me. Why do I have a squared on my absolute value? That is not a thing that we're dealing with at this point in time. It is a graph, but it's not the one that we're doing. So if you copied down my squared on top of my absolute value, please fix that. I'm sorry. That's weird. That graph definitely looks different. Okay. And then plus k is going to be a minus 2. Now I still need this a value. If I have a graph, I can just count. So rise over run, I would rise 2. And then to the left, 3. So I'd get a slope of negative 2/3 if I have a picture. If I don't have a picture, and I'm just given 2 points, then the same way as we did rate of change, I can find slope. So I would take a y minus a y and an x minus an x. To get negative 2/3 that way. Either way. So from the picture, or just if you're given 2 coordinates, you can find the slope. That goes in for A. Now, when I used my 2 points, or when I counted my rise over my run, I went to this left side both times. Remember that for an absolute value, right? Half of it has a positive slope and half of it has a negative slope, right? This is down to the right, this is up to the right. Be careful, because even though I calculated that this is negative 2/3, ask yourself, does the V open up or open down? It opens up, so it's got to be positive. If you write that negative there, that's going to be wrong. So again, this is going to be a positive 2/3 slope. This is going to be a negative 2/3 slope. But remember that the negative in front of here means direction. Since it opens up, it's going to be a positive 2/3. Okay, cool. That finishes up the 1.2